Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hello, everyone. Welcome to our new live stream series. This is Microsoft IQ Deep Dive with Python. This is a 3-part live stream series, and we're going to be exploring Foundry IQ, Work IQ, and Fabric IQ. We will even briefly explore Web IQ as part of today's session. So that means we are covering all 4 of the Microsoft IQ family in this series. And we're really focusing on ways that you can use these IQs programmatically when you're developing your own AI applications and agents, and especially when using Python. So if you have not yet registered for the series, please do register. So that way you get notified when the next 2 live streams start about Work IQ and Fabric IQ, and so that we can see you the entire week. So for today's session, we are focusing on Foundry IQ. You are welcome to take the slides and download them from the URL here, and we'll paste this in the chat so that you can get it for yourself. You can use these slides for whatever. You can deliver this session yourself and spread the word to your community and colleagues. My name is Pamela Fox. I am a principal cloud advocate, and I work at both Microsoft and GitHub. We're all part of the same company. And I really focus on ways that developers can build AI applications and agents, especially in Python, with all of our different Microsoft APIs, SDKs, and tools, and with GitHub Copilot and VS Code. So today we're going to cover a lot. I'm going to just let you know right now, we are covering a lot today. We're going to, brief overview Microsoft IQ, then really deep dive into Foundry IQ, and how we can set up Foundry IQ knowledge bases, how we can use it inside agents, how we can use it with Foundry Toolbox, and then how we can deploy agents that use Foundry IQ onto Foundry hosted agents platform and even use them from inside teams. So there's a ton we have to cover today. So I will probably be talking fast, but don't worry, because we do always record these sessions. You can always rewatch them. And if you have any questions, you're welcome to post them in the chat. My colleague Aicha is in the chat and she may be able to answer. Or even better, you can save your questions, because we're going to have a full hour of office hours right after this. So, because I won't have time to answer questions during it, that's why we're going to jump into Discord afterwards. So if you have any additional questions, we can really spend a lot of time of those questions in our Discord office hours afterwards. All right, so we are going to be showing a lot of code in this series, and we've put it all in the same repo. This is aka.ms/IQ deep dive. That will bring you to this Microsoft repo here, IQ deep dive. And this has all of the code we're going to show over the next 3 days. So we've got lots of Jupyter notebooks, lots of agents, lots of infrastructure. It's all in this repo. Now, in order to actually run this code yourself, you do need to have an Azure account and several licenses set up for the various IQs. So you may not be able to run it all yourself, but all of the code is available. And if you do have, Fabric license, Work IQ license, then you'll be able to run those examples as well. So definitely, clone the code, star the code. This is a reference for you to use with all of your IQ development. So now let's talk about Microsoft IQ, the point of this whole series. And This Microsoft IQ platform, the idea here is to provide all the kinds of intelligence information that AI needs. Because what we've seen is that LLMs are, incredibly powerful, but they are the most powerful when they are grounded in your domain's information, right? If you give them information, LLMs are so good at answering questions, at synthesizing information, at transforming that information from one format to the other. Like, it just makes it way easier to get back the answers we need when we have an LLM that can much more quickly look through all this information and synthesize it for us. So the idea of Microsoft IQ platform is to be this unified intelligence layer for your AI applications and to cover all the different kinds of information that you would need to ground your applications in. So we have Work IQ, which is how your employees work, and that's basically bringing in Microsoft 365 data. So that is, your Teams, email, calendar, SharePoint, Office docs, like all of that information that's spread across Microsoft 365, productivity suite. All of that would be from Work IQ, and that we're going to be covering tomorrow with my colleague Aicha. Then we have Fabric IQ. So this, if you're using Microsoft Fabric, that is a way that you can store all of the business data that's powering your applications. Like, you can have your relational data there. You can have your analytics data there, all your reporting data there, right? Everything can go in this Microsoft Fabric platform. And then you can use Fabric IQ in order to pull that back out in an agent-friendly way. So that we're going to be covering on Thursday and really going deep into that on Thursday. Then we have Web IQ, which is how we can connect to information from the web, right? We often need to get real-time information from the web, like news, weather, etc. Like, just make sure we're up to date with what's happening in the world, and that's what we can use Web IQ for. And then finally, Foundry IQ. This is really how we can bring any sort of information in. So Foundry IQ can actually bring in all those other sources, but it can also just ingest any sort of unstructured data we have, any sort of documents. You have piles of documents somewhere, stick them in Foundry IQ, right? And so today, that's what we're going to be talking about. So now let's talk deep about Foundry IQ. So Foundry IQ is trying to tackle the problem that your knowledge is everywhere, right? You've got knowledge in relational tables, you've got analytics data, you've got web, you've got SharePoint, you've got lots of PDF files, CSV files, text files, JSON files, Markdown files. There's so many different sources of information. So given that, information is spread across all these different file formats, how can we efficiently find the right information across so many different sources? So that's why we have Foundry IQ, is to be able to retrieve across all of these in a way that is, going to find the best, most relevant results for our applications and agents. So Foundry IQ, which is based off of Azure AI Search. So you can basically think of Foundry IQ and Azure AI Search as the same. So Foundry IQ is going to be able to take care of how to select the right places to find the information. Then once it's found the right source of information, retrieving from that source. Then if it's selected multiple results, merging those results together. And then finally, it can also synthesize an answer. So it can help us do the entire retrieval process. So how this works is with a Foundry IQ knowledge base. So this is a knowledge base that can do this multi-step retrieval process across multiple sources. So we start over here with the input, right? So the input very often is an entire conversation, right? Because many of our applications now are actually conversations based, like it's a chat bot or it's an agent, and you're having a little discussion with them about what you want. So we'll input that conversation and any additional steering instructions, and that gets sent to this retrieval planning stage. So the retrieval planning stage uses an LLM in order to decide, okay, based on this conversation, what do I think we actually need to search for? So it's going to turn that conversation into search queries and say, okay, I came up with a couple queries, and these queries, identify what information this user really needs in order to answer their question. So it comes up with, one or more queries, and then it sends all of these queries in parallel to selected knowledge sources, right? So you can connect a bunch of knowledge sources up to your knowledge base, whatever it is you need. You could have multiple search indexes, you could have MCP servers, you could have Work IQ, you could have Fabric IQ. You can connect all of those up to your knowledge base, and then, it's going to decide which of those knowledge sources to send it to. And it'll do it all in parallel. And that's really nice, because then the retrieval step is only going to be as slow as your slowest knowledge source, right? So then that way, we're not having to wait for sequential retrieval across each of them. We're just going to do all of that in parallel, and then we get back the results. So then with the results, it's going to merge those results together and re-rank them according to the original, user query, and say, okay, we got all these results across a bunch of different sources. Which of these is actually the best result for the query? So then it does this re-ranking step there. And that helps us figure out, like, okay, what are actually the best answers? We can also get an activity log, so we can see exactly what happened. And we can even have it synthesize an answer with its LLM if we wanted to. So that is, that's like the, a full agentic retrieval there that we can do with a knowledge base. So now let's dive into the different kinds of knowledge sources. So today we're really going to focus on index knowledge and putting stuff in a search index. So that, when we're creating a search index, that means we're creating a search index for unstructured data, right? And so that's stuff like PDFs, text files, things that aren't already in a database. So for those kind of files, we need a data ingestion flow. So this is the general data ingestion flow we're going to use. So we start off with our document, right? And it could be various formats here, like PDF or docx or HTML. Then we extract the information from that document, right? So there's a lot of information we want to get rid of, like, formatting information that's not important. But we do want to get out the text. We want to get out the tables, and we also ideally want to get out any figures, and that can be a bit tricky to extract figures, but ideally we also want to get back figures. So if there is an image in there, you want to pull out the image, you want to get a description of that image, and you want to know, where that image is relative to the rest of the text. So that's what a full extraction is going to look like. Then we're going to chunk that text into chunks that are, optimal for agent use later, because you don't usually, let's say you've got a 20-page document, you don't want to have to send that entire 20-page document to the LLM if the relevant piece of information is just like a paragraph on page 3, right? So typically we're going to, actually take that full document and then chunk it into smaller chunks. And usually that's based on number and tokens. So maybe we'll try and come up with a chunk that's like 500 tokens long approximately, or maybe even 1,000 tokens long approximately. And we might even try to do some semantic chunking and say, like, oh, if there's like a section, we're going to just chunk that entire section because that's about the right size. So there's various chunking algorithms you can use: character-based, token-based, semantic-based. But in the end, you want to have, around 500 or 1,000 tokens for each chunk. Then once you have the chunks, you want to embed those chunks using a vector embedding model. So that vector embedding model turns that chunk into a list of floating point numbers, which represents that text in a multi-dimensional semantic space, right? And so then once you have vector embeddings for every chunk, you can actually see for any particular user query, hey, which of these embeddings is, which of these vector embeddings is closest to this user query. So that makes our search more powerful, where we can search not just by keywords, but also by vectors. And then finally, once we have all the information we need, we can store it in the actual search index. So we're going to have an ID for each chunk, ideally a parent ID to say what document it came from. The path to the, the file path might be in blob storage, the actual chunk of text, and then the vector, which represents the embedding of that chunk in vector space with your particular vector embedding model. So that's oftentimes what you're going to store. You could also store some additional metadata, but that's kind of the bare minimum that I would store. So with the search indexes with Foundry IQ, there are two different ways that you could add index knowledge. There is a new way called the file knowledge source that tries to make it super easy to add files, where you don't have to set up a data source at all. You can just literally directly upload files to it, and we'll see that soon in Python. So there's no setup needed, just directly upload files. So this is a great way to get started, where you just want to start prototyping and not have to worry about setting up a data source. Now, usually when you move to production, you're going to actually set up a data source, right? So for unstructured data, it's usually going to be blob storage or data lake storage Gen 2. Or for relational data, like if you have like a Cosmos DB or Postgres DB, you can actually like set up indexers for your relational databases as well, right? There's a bunch of built-in indexers that can bring in data from different sources. So there you're going to configure a whole pipeline. You're going to make a data source, you're going to make an indexer, you're going to equip it with certain skills for, embedding and chunking, and then it's going to go to the index. So that's what you'll do, in production, and run that ingestion in that custom ingestion pipeline in the cloud. So what does that process look like for an ingestion pipeline, right? So you set up your data sources. And I was saying there's quite a few data sources that you can set up. There's even more than what I was able to fit in the slide here. And these are built-in indexers. So you can just tell Foundry IQ, like, hey, I've got this data source, it's an Azure table, and it knows how to connect to that data source and run an indexer for it. And it'll add change tracking. So what's really nice is that with these data sources, we've got built-in support for change tracking. So it'll say like, oh, okay, like it'll, run every 5 minutes or 10 minutes or whatever, and say, oh, I see there's a new file or a new row or something's been deleted or added, right? And then, it'll run that and see like, oh, there's a new file. When it sees there's a new file, then it's going to run its skill set, right? And you can use built-in skills, or you can also run your own skills, which are Azure functions. But there's a lot of built-in skills, so you always want to start with that. So we've got the built-in skill content understanding, and that's the one that's going to do the document extraction that I talked about. And that one can even understand images, figures, tables in your documents. Then we've got the split skill, and that does the chunking I talked about. And then we've got the embedding skill, which will connect to like an Azure OpenAI embedding model. So there are tons of built-in skills, and you would put them together into a skill set to make this like pipeline of skills. But you can also build your own custom skills using Azure functions. And you can customize the built-in skills to an extent. Like for the embedding skills, you can connect that to any of the Azure OpenAI embedding models. But if you needed to connect that to a completely different embedding model, in that case, you probably want to build your own skill. So once again, if you do realize that you don't have the flexibility you need in a built-in skill, instead you'll make an Azure function, and that Azure function will, it'll receive the input, which would be like a document, and then it'll, run whatever code you want it to run, and then it'll output, output whatever it's created, like an embedding. And then finally, the output from this whole ingestion pipeline goes into the search index. So once we have our knowledge indexed, then how does retrieval actually work? So with Foundry IQ, we get the best retrieval strategy, which is a hybrid search stack. Hybrid search means that we're using both vector and keyword search combined. And that is really, really important in order to get the best results for all sorts of user queries. You might hear people talk a lot about vector search these days, and vector search is amazing, but it cannot answer every single user query. You really need a combination of vector search and keyword search together, right? So with this index, when we have a search index and we search across it, we get in a user question, and then, in that we do both a keyword search, and that will, do any direct matches of the keywords. Then we also get vector results, and so that's good if the words might be completely different, but they might be semantically similar. Then we use this fusion step, which uses an algorithm called reciprocal rank fusion that just merges the results together based off the relative rank of each result in like the sub results. So it'll, re-rank according to that. And then we send to an actual re-ranking model. So this is a special model that has been developed specifically for the task of re-ranking. So it looks at the original user query, it looks at the results and says, hey, for this user query and these results, do I think this is the optimal ordering, or do I want to reorder it, right? And this is not necessarily an LLM. It's often a cross-encoder model. So it's faster than an LLM. But it's really helpful to have this step, because that way you can take the 50 merged results and then re-rank them and then feel confident that like the top 10 are the most 10 relevant results. Okay, so now we've seen how we can set up a search index and do ingestion and get great search on just that search index. So now let's zoom back out to knowledge bases, which can put together multiple, knowledge sources. Include multiple things. So let's talk about how we can configure a knowledge base, right? There's actually multiple effort levels for a knowledge base, from minimal to low to medium. There is no high right now. They're still deciding exactly how this is going to look. I actually think what they're going to add might be an auto instead of a high, but we'll see. So we're going to look at these options here. So let's start with minimal. So this is a knowledge base with minimal effort. So it actually does not use any LLM at all. That means that you need to send it, however many search intents or queries you have. So you come up with, that list yourself, and then it will send, it can send all those in parallel to every single source. So every source you have configured, it will send them in parallel to every single source. And then it gets all the results back. It does have a re-ranker model for merging, so we will get re-ranked results from all those results. So that is actually really helpful still. So this minimal mode, it is definitely minimal, all right? Like we don't have the query planning from before. We don't have the source selection where it decides which ones to search for. But we still get parallel search execution, and we still get result merging with a re-ranking model. So this minimal effort mode can still be really helpful for a lot of cases, and we're going to actually use it for our agents later. So you're going to see that for agents in particular, minimal effort can be a really good fit. Here's an example of, minimal effort, right? So we have an input, and in this case, I just have one input, but I could pass in multiple intents, as we call them, or queries, right? And so it's going to search, and in this case, it's going to search across every source, like a search index and a SharePoint, and then it gets back the merged results, and each of them has a re-ranker score, and then we can use those results. Now let's go to low effort. Now this low effort, this looks like what I showed earlier, right? So this time we bring in an LLM. The LLM does the query planning stage, or retrieval planning. So that's where it just, looks at the conversation, decides on the search queries, and then also does source selection. So it says, oh, for these queries, I think we only need, this search index and Fabric IQ, and then we don't need these other two, right? So it can decide whether to ignore sources. So this is particularly helpful if you do have a lot of sources that are connected to a particular knowledge base. It can help to, make sure that you're not wasting queries when it's very clear that, a particular answer won't be found in queries in a particular source. So then it does it across all of those, and then we get the merge results, activity log. And if you want, you can even have it answer the question yourself, because it has an LLM. So of course, an LLM can also answer the question itself. So this can potentially this can do the entire flow. You don't need much else because you've got an LLM, right? So it can do the entire flow from a user's question to the answer. So here's the example with low effort, right? We get the question here, and then it does the query planning stage, and that, uses a certain number of tokens, and we can, see how many tokens it uses. And it comes up, in this case, it comes up with multiple queries, right? So it's searching for, bathroom paint and then paint prices, right? And in this case, it decided only to search the search index. So it sent those two queries, both to the search index. Then it did re-ranking and then finally synthesized the answer. So here we can get the results and we can also get the answer. Finally, we get to medium effort. So medium effort is a mode where we'll actually do a second retrieval. So what happens here is that it gets to the output here, and it looks at the results, it looks at the question, and it uses a this keeps going around. Sorry. So we get to these results, and in this mode, it will actually use another model, one that they specifically trained, in order to look at the results, look at the user's question and say, hey, do we have enough information to answer this question? Because sometimes it might say like, listen, we got a bunch of results, but we still don't have enough information because, maybe we didn't do a good enough search. We didn't realize what additional information we needed, or maybe it's kind of like a multi-hop question where in order to really answer it, you need to first get some other information from there, right? So it's going to use this special model in order to decide, do we need information? And if that model says, yes, we do need information, it's going to do an iterative retrieval and say, all right, we're going at it again. We're going to do another step. And this definitely is going to take more time because it's going to go through the entire process again. But sometimes it is needed for those complex multi-hop questions. So here's an example of, medium effort. So in this one, the activity log is much longer because it actually goes through multiple steps, right? So, this is a more complex question. So it does a first round with 2 queries to 2 different sources. So that's 4 retrievals. Then it says, we don't have enough information. It realizes it needs to search for more information. And so it does another round with a query to both of the indexes, and then gets back the results and comes up with an answer, right? So it's going to take a lot longer, but, potentially give you a more complete answer. Okay, so those were the effort levels, and it's good to know about all the effort levels because there's some situations where, it's appropriate to use the minimal, some low, some medium, and you just want to be able to decide for yourself what's going to be best. As I mentioned, they are looking into doing something like an auto mode. If you've used like GitHub Copilot, it has an auto mode for like the model picker, right? And kind of same idea, because sometimes maybe you don't know, what effort level is best. So if there's an auto mode, maybe it will decide for you, right? So how do we actually do this in Python? Let's just go over to the notebooks now. We haven't shown any of the code yet. So now I think we've got a good basis, and we can start looking at some code here. So I'm in notebooks, the notebooks folder. There is Foundry IQ-basic. That's the notebook that I'm looking at here. And you can explore this in the repo. In the repo, we have checked in all the notebook outputs, so you can see everything that I'm about to run. So first, I'm just going to load up my environment. I've got everything provisioned. And so first, I'm going to show that file knowledge source. Remember, I said that the file knowledge source can be the easiest way of getting started. Let me make that even bigger. And this one we can directly upload to. So I actually have, a local file here. In this case, it's a markdown file. So it is actually doing that upload right now in, just in this notebook. It is uploading that to the file knowledge source. And we can see this does take, I think, around 35 seconds because it's doing that entire pipeline, right? So it is doing the extraction of the text, it's doing the chunking, it's doing the embedding. And there we can see it finished after 25 seconds. Okay, so now this file is in that knowledge source. So that's all set up. So for, this is the minimal setup you can do if you just want to start quickly using a knowledge base and don't want to have to set up anything separate. So then we're going to create a knowledge base. So for this one, we set up, we're going to set up we're going to set up an LLM. So say, here is our, here's our LLM deployment. This is only compatible with the Azure OpenAI models right now. Like I'm using GPT-5.4. You can use most of the GPT-4, like from 4.0, 4.1, 5.4, maybe 5.5, not 5.6 yet. Tried it yesterday, so we'll work on that. But generally, I tend to use 5.4. So we set up the LLM. Then, then we're setting up the knowledge base, right? So we say, here's our knowledge base. We give it a name. We give it a model. And then we give it knowledge sources. So in this case, we're only giving it a single knowledge source, and that's that file knowledge source that we just set up. And we're telling it to use answer synthesis mode. So it will actually come up with an answer. So it's going to use that LLM to come up with an answer. And there we go. Let's run that. Okay, that's done. So now that the knowledge base is set up, now we can actually query it, right? So we're going to create a retrieval client for that knowledge base. And we can customize, the way in which we use each knowledge source. So here we're saying, okay, I want you to include the references so that we can see the citations. And here's a question I'm passing into it. And I construct my conversation. So, I'm saying, oh, the user is asking this. So this looks like a conversation somebody is, having with a chatbot or an agent. And then I tell it to retrieve it. So here it is going in, it's doing that full knowledge base process. And now it's done already. So it's after 5 seconds. That's pretty good. So now we can get the answer. And what you'll notice is in the answer, we have citations. And that's really, really important, right? Whenever you're getting answers that are grounded in results, you really want to have citations. So when you use this answer synthesis mode, it will ensure there's citations there. If you're writing your own application, then you just want to make sure in your prompt, you're telling it like, hey, here's your references, make sure you do citations. So these citations will tie to the references that we can pull out later. So you can actually make a linkable interface to those citations. So then we have the activity log. So this is really helpful for understanding what happened, for debugging that entire knowledge base process, right? So when we look at this, we can actually see, okay, it did do query planning, and then it sent, we can see what queries it sent. So it sent this query to the file knowledge source. It sent this query to the file knowledge source. It sent this query to the file knowledge source. So it actually, in that query planning stage, this one came up with 3 different queries and decided to send all of them to the file knowledge source. And then it did the answer synthesis step. And these are the re-ranking tokens here. So that's the activity log here. And this is super helpful to understand why an answer is working as well as it does. I saw there's questions about doing evaluations. We don't have time to talk about evaluations in this series. I do discuss that, in a lot of my other videos. It's really important to set up evaluations. And generally when you are doing evaluations, I would give your evals access to the activity log, because I think it can be really helpful for understanding why something went wrong. Or at least when you look back at your evals and see something's a failure, you really want to look at this activity log and see why. Like, was the problem in the query planning stage? Was it with the ingestion? Like, so many things can go awry, right? You could realize like, oh, my ingestion's not doing a good job, or the query planning's not doing a job. Let me try a different model, right? So you really want to look at that activity log to give you an insight for what's happening behind the scenes, right? Because you really can't look at just the output and know why it's good or bad. You really need to look at the whole process. And then we can also look at the references. These are the same references that are referred to in the answers, right? And so we can see like, okay, reference 0 is this one, and that's where it got most of its answers from. And we can see, that this is the file path that it came from. So we could, tell people like, oh, but, this answer came from, this file. And if you're developing an application, you can pop open that file and make it so they can browse the entire file. Okay, so there we go. So that is doing a file knowledge source. Now let's look briefly at an index knowledge sources, because this is what you're going to, well, both of them are indexed, but We call this one an index knowledge source. Ultimately, everything's stored in, they're both stored in index. But these are ones where we're actually setting up we would set up a proper index or pipeline. This is what we would use in production. So we've already set up the indexes here because that takes some time. So that we've got two indexes, one with 50 chunks and the other one in 334 chunks. You can see it says documents, but you can really think of those as document chunks. And then based off those search indexes, we create a search index knowledge source, right? So this is just us describing and saying like, hey, we have these search indexes. We want you to create a knowledge source based off these search indexes. And, here's what you're going to be searching, the fields you'll be searching in those search indexes. Then we can create another knowledge base. So this knowledge base is going to have the same LLM hooked up, but in this case, we are giving it those two knowledge sources. So we're actually making a multi-source knowledge base. And that way, it's going to have to decide whether it's going to send the query to all of the knowledge sources or just one of them. So then we can go and ask it a question. And we're giving it a bit of a complex question here. So it's probably going to query both of them. So here we got back the answer quite quickly. And so we can now look at the activity log and say, okay, all right, what did it do this time? It sent this search query here to this knowledge source. It sent this one to the same knowledge source. Actually, it looks like, and it did actually send queries to health docs as well. Okay, so it decided to query both the knowledge sources. So it sent 3 queries to each of them. But you see, it was like very fast, right? So it's actually doing a lot of searches, but since it is doing them in parallel, it is able to do it very quickly. And then we can review the references. So there we go. So those shows you, setting up a knowledge base, your simplest way with a file knowledge source, and then more complex, with actually properly setting up a data source and an indexer pipeline and all that stuff. So there we go. Okay. All right. So that was, that was a basic multi-source knowledge base. We're going to keep making knowledge bases, in the course of this series. So we'll be hooking up WorkIQ and FabricIQ. So we're going to keep seeing knowledge bases. The first thing we're going to hook up today is WebIQ, right? So now we're moving from index sources to remote sources. So these are cases where like the data is not indexed in Foundry IQ itself. The data is somewhere else, but Foundry IQ can still reach out to remote sources and get that data and merge it in with your index data. And that's what's helpful about Foundry IQ is the ability to combine your index data with remote data. Because realistically, some data is indexed, some data is remote. We want to be able to bring them together. So let's talk about Microsoft WebIQ. This was just announced at Build, super new. It is a web search service designed specifically for agents. It is very, very fast, super duper fast. I'm very impressed with its speed. Because they really did a lot of work on the speed and on making an architecture that would be able to be really fast. And when you have WebIQ, you do get access to the full like content in an agent-friendly format. So it's usually you can get Markdown, summaries, HTML. Like you can actually get access to all of that. So it's a very good service. It's so good that's only in private preview right now. That's the big drawback is that right now you do have to apply for it, access to it, and it's only being tested with a few Azure customers right now. So obviously we're all very hopeful that it's going to get rolled out, to more broadly so that more people can play with it because it is a very good service. But they're also designing it in a responsible way, right? They're working with web publishers to make sure that this is working for web publishers as well, like it's so that it's not, stealing, like ad revenue from people who are running websites, right? So they really worked a lot on both speed and like performance, but also like how can this be something that works for both agents and works for people making websites. So we're going to be using WebIQ as its MCP server. It has an MCP server that once you have access and once you have a key, you can call that MCP server and then get back results. So you'll get back title, URL, content, a crawl date, and a language, right? And you can see there's actually multiple tools that they have. So they do have like different tools for like video versus news. We're going to be using the web tool so that we can bring in web results. So let's see how we can do that. We're going to go to the WebIQ notebook here. I have a WebIQ key, thanks to having some friends on the WebIQ team. And yeah, so once we have that, then we're going to set up the same search index knowledge sources from before, just to have those. Then we're also going to set up this MCP server knowledge source. So with Foundry IQ, you can bring in any MCP server. And in this case, we're bringing in WebIQ. So we're saying, okay, this is, this is what we're bringing in. This is the URL of the server. This is how the authentication works. We're going to send along this header, and this header is going to contain the key, right? So you can bring in any MCP server as long as you're able to connect to it, with the right authentication. So in this case, we can send in the key and say, hey, we're going to use the tool named the web tool. So now our knowledge base can decide that when it's going to use this web tool. So then we go and we create, I ran that. Then we're going to go and create the knowledge base. So we're going to connect it up to both the index knowledge sources and the MCP knowledge source. And you'll see I added some instructions. I said, use the HR for company policy questions and use WebIQ tool for context from public web pages. So when you start to add more knowledge sources to your knowledge base, you are going to want to, give it more instructions. This is called the retrieval instructions. You want to give it more instructions about when it should use what, right? So, it's just going to help it make a better job deciding. And then we're going to query. So in this case, we're asking it to check for mental health coverage. That's from the internal docs. And then it's also going to search the web for industry benchmarks and for mental health at other tech companies, right? And so you see it finished, and it finished in just 16 seconds. And that did all of those searches, right? So we got all this information from the internal docs. Then we got all this information from the web, and then it does this summary here. So really, really comprehensive. So it's very helpful for these sorts of questions that, where you want to have some information, from the broader web. So then when we look at the activities, we can see, let's see, here it is. So MCP server. And we can see that it sent this query to it, like current industry benchmarks, so that's the query it came up with to send to that MCP server. And then when we look at the references, that's when we're going to see the results. So you see for the MCP server, the references is actually JSON here that has, you can see title, URL, and then there's a bunch of content in here. It keeps going for long time because it's got all this content here. So there we go. So now that shows, connecting to this WebIQ server. So that is a remote server. When it is a remote service, that data is not getting stored in an index at all. It's just being incorporated into your results. So it does go through the re-ranking model at the end in order to merge it, but it never gets stored in like an actual index, right? It stays remote and fresh. Okay, so now we've seen, Foundry IQ, multi-source knowledge bases. We've hooked them both the index knowledge sources and a remote knowledge source. How do we use Foundry IQ inside agents? First of all, what is an agent? I've talked about them a lot today, but I always like to make sure we have a definition of what an agent is. An AI agent uses an LLM to run tools in a loop to achieve a goal, right? The goal is often answering a user's question, but it's just any sort of goal, right? So the LLM has, the agent has an LLM that knows about all these tools it has access to. It can look at the input and say, okay, based off of this question, what are the tools I need to call? And it'll keep calling tools until it feels like it has enough information in order to answer the original question, right? So that is an agent. And it's a very simple concept, but it turns out it's so powerful once you hook it up to the right tools that can, achieve goals, right? So you can, you can make these really, really incredible agents just by giving them access to the right tools. So when I think about using Foundry IQ as a tool for AI agents, there are 3 main options that I would recommend, and these all can work for different scenarios. So the first option is to write a custom tool ourselves that calls the knowledge base using those API commands that we just ran in the notebook, right? And that will give us full control over everything because we're writing the code ourselves. Option 2 is that we can point at the knowledge base's MCP endpoint, because every knowledge base exposes an MCP endpoint, and that's for greater portability. And that's just easy because all agents know how to work with MCP servers, and so that might just be the easiest thing to do. And then option 3 is we're going to try out using Foundry Toolbox, and that can be helpful when we want to bring in other tools as well. So we're going to show all 3 options here. Now, first of all, when we're doing, when we're using knowledge bases with agents, which of those retrieval efforts do we want to use? For these examples, I decided to use minimal, right? The reason I'm using minimal is because I have an agent, and the agent can handle the query rewriting and the iteration. The one thing the agent can't do is the source selection, because that's not something that can be controlled from outside the knowledge base. But that I'm okay with that, right? So I'm going to use the minimal knowledge base because I'm writing my own agent, and that agent can do the query writing and the iteration. But you might decide that for your use case that you may want low or medium. If maybe you really like the query rewriting and iteration that the knowledge base itself is doing, right? But since because here's the thing about a knowledge base. A knowledge base is itself agentic, right? It has these agentic abilities. So we have to decide how much of the knowledge base's own agentic abilities do we want to use versus relying on our agent's abilities. So in this case, I'm going to use minimal and really rely on my agent's abilities. So let's look at this first example here, right? So this is, underneath here, we've got a bunch of agents under the source folder. So the first one, agent Foundry IQ API, right? So this is an agent that's using Microsoft Agent Framework in order to build the agent. So you can see the agent code here. And I gave that agent access to 3 tools. So 2 of them are just date tools like get enrollment deadline, get current date. And then this one, retrieve company knowledge, that's the one that sets up a retrieval request. So it says, hey, I need a list of queries. And then it sends those queries to the knowledge base. And this knowledge base is using minimal. So it's sending it to a minimal knowledge base. And then it's sending back the response, the references, and the activity. So it's sending back all that information because it could be helpful for the agent to reason about, whether it needs to do another call, right? So this is our custom tool, and this is a custom tool, so we could write this any way we wanted, but this is what I came up with here. Okay, so then we can let's actually run that. Oh, let me go ahead and run that tool. Here we go. So I'm running it using the AZD AI agent extension, which works really well with Foundry agents, which we're going to turn this into a Foundry agent as well. So this is running locally, and then it's going to, I can pop it up over here. Okay, so it pops open this playground. Just make sure it's working. Hi. All right, working here. And so we can actually check the logs and see everything that's happening here. You can see all the requests going up over the network, and we'll just say okay, we'll just send a question here. what benefits are available, when do I need to enroll. And so that is sending to the agent, and the agent's going to decide, okay, which of these tools am I going to call in order to answer this question, right? And so remember, it's got, it's got 3 different tools it can call. One of those is a tool that calls the knowledge base. And if we go here, we can see, lots of, things that are going over the wire here. And let me open up this again so we can see the code. All right, still working on it. Of course, with live demos. All right, still sending here. There we go. Okay. Ooh, it said it all exited. Let's see if my Oh, there we go. Actually, I see a bunch here. Okay. All right, there we go. So now it's all done. Okay, so everything came back now. So here we can see these are the queries that got sent. And this is my agent did the query writing here, right? Because I just told the agent, hey, here's the tool. It takes a list of queries. And so my agent decided, all right, I'm going to, take this question and turn it into these queries, right? And in this case, it just came up with a single query, it looks like. Models will vary widely based off how, depending on what model you're using, you're going to see very different query writing. That's one of the biggest factors actually when you're doing something like this. So you definitely want to pay attention to query writing. You may want to give it more instruction, come up with this number of queries, split them this way, whatever. But that's definitely can affect your output, your retrieval quality. And then we get back the response. This is the response, from the API, and we put everything in it. So we've got the references, we've got the activity log, we've got it all. And then we get back the answers, and then it combined it with results from the other local tools here. So here we go. And that's working really well. So that is a definite option. The next option is to use the MCP server as the tool, right? So I was saying every knowledge base exposes an MCP endpoint, and that MCP endpoint is, going to execute the knowledge base behind the scenes and do all the steps based off whatever effort level you configure the knowledge base with. So that's going to look a little bit different. So that's in our MCP folder. Okay, All right, so what we do here is we say, hey, this is our knowledge base, and this is its MCP endpoint, right? So you can construct this just knowing your search endpoint and your knowledge base name. And then we make sure it has its credentials, so it is able to, send the right token to it, because we're using, Entra-based OAuth credentials here. We set up the tool. We say you're going to be able to, this is the tool name that every MCP, knowledge-based MCP server exposes. And and so this way, instead of that local function, it has that MCP tool instead. And it's just going to work the same way. So I'm not going to keep showing each of them just because of the amount of time we have left. Because it's going to look really similar, right? It's going to send it off, and it'll, make a query. Here I've got a screenshot, right? So, in this case, it calls the knowledge base retrieve tool, because that's what it's called on the MCP server, and passes in a list of queries because it expects the same thing, and then we get back the results. Now let's talk about Foundry Toolbox. Foundry Toolbox is part of the Foundry platform, and the idea here is to make it super easy for you to compose a bunch of tools together and expose them to your agents, and it particularly makes authentication easier. So it can be really, really helpful when you're dealing with tools, and it also just gives you access to built-in tools like webs. There is actually a web search tool in Toolbox that's different from WebIQ, so you're not going to get the same results there, but there is a web search tool there. There's also a code interpreter tool that one I really like, that does sandbox Python execution. But it's also going to give you access to WorkIQ, FabricIQ, any MCP server, right? So the cool thing about Foundry Toolbox is that you can put together all these tools, and then Foundry Toolbox itself is actually an MCP server, right? So it's like an MCP server that can combine all these other MCP servers or other built-in tools. So we can construct a Foundry toolbox from code. So it's one way you can make a toolbox. You can also just make it in the Foundry UI. And so here I'm making a toolbox that has the web search tool, the code interpreter tool, and the MCP, an MCP tool for that knowledge base, right? So we're once again using the Foundry IQ MCP server in order to add it to the Foundry toolbox tools. So we create that toolbox. And then we can use that inside an agent. Now with Agent Framework, it's actually super easy to use it because they even just decided to make a class for it. So there's this Foundry Toolbox class. So all you have to do is say like, okay, I'm making a toolbox. I'm using, here's my credential, here's my URL. And so you can see that the toolbox itself is an MCP server. So we actually point it at the MCP endpoint for the toolbox. And then when we make the agent for the tools, this time the third tool is the toolbox, right? And that toolbox has both the Foundry IQ MCP and the other two tools as well, right? And we can keep adding other stuff to that toolbox. So then when we run that, we're going to see really similar results. There you will see that there's like the tool has a prefix at the beginning just to show where, what subtool it came from, since now we're using like a toolbox of tools, right? So it's, but besides that, like everything pretty much looks the same. So this can be, a really helpful thing to use. And the nice thing about toolboxes is that they're more reusable too. So if there's a certain set of tools that you're using across multiple agents, you can make that toolbox once, and then you can use that toolbox from other agents, right? Okay, we got 5 minutes left. So let's talk about deploying agents. How are we going to actually deploy those agents that I just showed? Because it's great that all this works locally, but obviously we want to use this in deployment. So we're going to show how to use Foundry Agent Service. And the goal here is to make it super easy to host our agents. The agent service has two kinds of agents, prompt agents and hosted agents. We're going to look at hosted agents where we get to bring our own code to it and really be able to customize it more. So with Foundry hosted agents, in theory, we can serve any agent as long as it supports the responses API. So we use this responses API. This is from OpenAI. We use that responses API as like our compatibility layer. And then we have our code. Our code exposes a responses API endpoint. And then that gets run in this container app sandbox, which is this super fast micro VM isolated environment. And then, the agent service takes care of identity and scaling, observability, all of that stuff. Evaluation, people ask about evaluation. It takes care of all of that stuff. So as long as we use Foundry hosted agents, observability, scaling, evaluation, all of that becomes really, really easy. So that's what I would recommend if you do want all of those just out of the box. So this is what it looks like when you're using Agent Framework. Agent Framework does have a built-in adapter. So you can use the Agent Framework hosting package and import the responses host server. And then you just take your agent class, you wrap it in the responses host server, and this exposes your agent using this responses API compatibility layer and then runs it, right? So I've actually got those. You'll see that at the bottom of all of mine is that they get wrapped in this responses host server, and that's how I'm able to run them as Foundry agents. And so then it gets deployed on Foundry. So then I can go, here. So I've got it and be like, okay, this last question, cover scuba diving, right? So now I can interact with it from, this is the Foundry playground, and we can actually see these are all logs from the, from the container environment. And we can watch the logs. We can see traces, right? Traces are really helpful. The first trace isn't going to be very exciting, but this is all using like open telemetry. So we can see everything that's going on. Here we got back an answer, and, the answer has all the information. We can check the traces here. We can see in the traces that it did use the Foundry toolbox in order to execute the knowledge base tool inside the toolbox. So really good observability. And then you can, add on evals very easily as well. There's also one-click publishing. So I have 1 minute left. You can do this one-click publish to teams. And, I tested it out and it does work. So here's the setup, right? You click this publish. That will create an Azure bot service behind the scenes, and then you can add it to your Teams. And in Teams, you'll say hello to it, and then you'll sign in, and then you can start chatting with it. So the goal is to try and make it really easy to do what you want to do, and everyone wants to publish to Teams. So you should be able to follow this process and use it in Teams too. Okay, all right. So we covered a lot today, and I know there were lots of great questions in the chat. I was trying to keep one little eye on them. Luckily, we do have office hours right now. So as soon as I say goodbye here, I'm going to pop over to Discord and start up the office hours there. We're going to be in the community calls 2 channel. So there are 2 channels for office hours there. So you're going to join. Make sure you find me in the community calls 2 channel. And there I can answer questions. If you're unable to use Discord, I know there were some mentions that some people can't use Discord due to company policy. You can also post your questions in this resources thread here. We're going to put the resources thread in the chat. I'll just put it here too. You can always post a question here. This is a discussion thread, so I'll see if you post a question in there if you're unable to join the Discord, right? So we'll try to get all the questions answered, whether we get answer them in Discord or in the discussion forum. We will try to answer them all. And you can, grab all resources from this resources page here. I will be continually putting slides. I'll make these write-ups. I'll put office hour recordings there. We'll try to put everything here so that you can keep up to date with everything. All right. So I hope to see you in the Discord, and also see you tomorrow for Work IQ. That'll be with my colleague Aicha, who's an expert on that. And then Thursday for Fabric IQ, and I'll be back for that one. All right. See you all. Bye.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.